Hello everyone, I am Dr. Vivek Saxena. Today I will cover the topic DC circuit fundamentals of subject Fundamentals of Electrical Engineering. Firstly, we will talk about the basic terminology of DC circuit fundamentals that covers circuit elements, network of circuits, types of elements, and Kirchhoff's law. Network or circuit is defined as an electrical system is an interconnection of electrical elements. In general, an input is applied to the system, then the system performs the desired function and results in a response. Basically, network or circuit consists three types of elements. These elements can be categorized in three categories. First one is resistance, inductance, and capacitance. As you can see, this one is the resistance. This one is the symbol of a resistor. And electrical resistance is the property of a material by virtue of which it opposes the flow of electrons through the material. Thus, resistance restricts the flow of electric current through the material. The unit of a resistance is ohm. Our next element is inductance. This one is a symbol of an inductor, and inductance is the property of a material by virtue of which it opposes any change of magnitude or the direction of electric current passing through the conductor. The unit of inductance is Henry. And our last component, the main component, is capacitance. This one is the symbol of a capacitor, and the capacitance is defined as it is the capability of an element to store the electric charge within it. A capacitor stores electric charge in the form of electric field being established by two polarities of charges on the two electrodes of a capacitor. The capacitance can be measured in terms of farad. Now you can say there are three basic elements of electric circuit. First one is resistance, second one is inductance, and third one is the capacitance. Resistance is the property of material which opposes the flow of current. Inductance is the property of material which opposes the change of current, and capacitance is the capability of element which stores the electric charge. Now, if we talk about the categorization of elements, such type of elements can be categorized into various categories, but in this lecture we will cover only three types in three categorization of material elements. First one is linear and non-linear elements. If we talk about the linear elements are those elements which have linear VI characteristics. Example, resistor, inductor, and capacitor. It can also define as the linear elements are those elements which obey Ohm's law. Vice versa, if we talk about the non-linear elements are those elements which have non-linear VI characteristics and they do not obey Ohm's law. The example of non-linear elements are diode, transistor. Next categorization is active and passive elements. Active elements are those elements which enhance the energy level of the circuit. The main example of active elements are voltage source, current source, and transistor. Vice versa, if we talk about the passive elements are those elements they do not have the capability to enhance the energy level of the circuit, or they cannot enhance the energy level of the circuit. Example, resistor, inductor, and capacitor. Next categorization of elements are unilateral and bilateral elements. Bilateral elements are those elements which have same VI characteristics with respect to their terminals. The example of bilateral elements are resistor, inductor, and capacitor, or vice versa, we can say unilateral elements are those elements which have different VI characteristics with respect to their elements. If we are changing their terminals, then the VI characteristic of such type of elements will be changed. Example, diode, operational amplifier. As you know, diode can be operated into two mode. First one is forward bias and second one is reverse bias. If we are using diode as a forward bias, the characteristic will be different from if the diode is working in the reverse bias condition. So these are the main categorization of elements: active elements, passive elements, unilateral elements, bilateral elements, and the first one was linear elements and non-linear elements. Now this one is the basics of DC fundamentals. Now we will talk about the Kirchhoff's law. A German physicist, Gustav Kirchhoff, developed two laws enabling easier analysis of an interconnection of any number of circuit elements. The first law of Kirchhoff's is Kirchhoff's current law, and the second law of Kirchhoff's is Kirchhoff's voltage law. Kirchhoff's current law is the algebraic sum of all currents at any node or junction is 0. As you can see in this diagram, at this particular node, 5 branches are interconnected. 2 branches consist outgoing current and 3 branches consist incoming currents. That's why we have taken in this expression I1 plus I2 minus I3 minus I4 minus I5 is equal to 0. I1 and I2 are the outgoing currents and I3, I4, I5 are the incoming currents. That's why we have taken I1, I2 as positive and I3, I4 and I5 as a negative. Our next Kirchhoff's law is Kirchhoff's voltage law. In short, we can say this one is KVL. KVL in any mesh or loop of a circuit, the algebraic sum of voltages is 0. As you can see in this diagram, in this circuit, there is only one mesh and 3 sources are there, E1, E2 and E3, and the voltage drop across the resistors are V1, V2 and V3. If we are moving with the direction of current, then E1, if we are taking E1 as a positive, then V1, V2, E2, E3 and V3 are opposing the flow of current. That's why we have taken these voltages as a negative. The final expression is E1 minus V1 minus V2 minus E2 minus E3 minus V3 is equal to 0. Now this one is our Kirchhoff's voltage. If we talk about the applications of Kirchhoff's law, it is used to find voltage or current or both in any element or branch of the circuit. With the help of Kirchhoff's law, we can find voltage, current in any branch of the circuit. Another application, mesh law. Mesh analysis is based on Kirchhoff's voltage law, while nodal analysis is based on Kirchhoff's current law. The main limitations of Kirchhoff's law are it cannot be used for high frequency circuits and it also cannot be used for distributed parameter system. So these are our DC circuit fundamentals. Firstly, we have covered the types of element, the main categorization of element, what are the elements are there. First one is resistance, inductance and capacitance. These are the main elements of a circuit. Then the types of elements we have covered linear elements and nonlinear elements. After that, active elements and passive elements. After that, by unilateral elements and bilateral elements. After that, we have covered Kirchhoff's law. What is Kirchhoff's current law? What is Kirchhoff's voltage law? And what are the applications and limitations of Kirchhoff's law? These are the DC circuit fundamentals of basic fundamentals of electrical engineering subject. These are the reference books you can be referred. for the study purpose. Thank you.